So in this starter question, we've been asked which two equations are equal. So there's more than one way of doing this. You could try and say, okay, because they look like straight lines, I can try and rewrite them all as y equal mx plus c. Or the other easiest way to do this is, if you look at them, they've got 6y equal 8x with the 12 there, then 3y 4x 6, 6y 8x 2, 3y again. So maybe what we could do is rewrite these as 3y equals something, for example. Because when you look at 6y equal 8x minus 12, you can divide by 2 both sides. So remember, you keep the balance. So by doing that, let me bring a red pen. So this one, I could rewrite it as 3y equal 4x minus 6. So that's for this one. This one will be 3y equal, so negative 4x comes on the other side, 4x plus 6 come on the other side, minus 6. This one would be 3y equal 4x, because divide by 2 plus 1. And this one, if I want to make it positive, I need to divide by negative 1. Then I get 3y equal 4x minus 6. So I'm looking at all these. 4x minus 6, 4x minus 6, 4x plus 1, 4x minus 6. So I've got three equations here that are equal. That one, that one, and this one. Whereas this one is not. So I'm just checking to make sure which two equations. These two are equal. So I wouldn't have put that as this question. So 3y equal 4x minus 6. 3y equal 4x minus 6. And 3y equal 4x minus 6. So I've got three equations here.
But that's minus 3y.
So what I've done is I've divided that side by negative 1. So if you divide that side by negative 1, you're allowed to do that, but you need to do the same for the whole thing. You divide by negative 1. So negative 4 divided by negative 1 is positive 4. And 6 divided by negative 1 is negative 6. So you can rewrite this as this.
But surely that's not what the question's asking. It's only asking for two equations, not three.
Yeah, so maybe the question is not worded properly. Which
If that was me,
equations?
I'd then look at that and think that I've made a mistake.
Yeah, that's why.
Yeah,
That's why I was double checking. So it's probably not worded correctly. I would probably say which equations are equal, and then you could say these three are equal and this one is not. Or pick the odd one out. Could be another way of doing this. And this would be the odd one because it's different than the other three. Yeah, so I'll rewrite that. Okay. So yeah, it's a couple of ways again to do this, like I said, but you should get the same answer. So if you get a different answer, let me know. That'd be interesting. Okay, so today we're looking at quadratic functions. I'm going to call that quadratic function 1, so part 1, because it's going to be, I think in your book you've got 4 chapters that talks about quadratic. I'm going to try and see if we can combine them into 3. So the first lesson is to try and explain the basic quadratic function. So the basic one is y equal ax squared. Okay, So we'll look at properties for quadratic function, and we are going to look as well the links that exist between a graph which is y equal x square and y equal ax square. So x square just means there's an invisible 1 here. It's when a equal 1, you get x square. But if a is different than 1, you get ax square. Okay. So every time you're going to see a function that has got that form, ax square plus bx plus c, we looked at some of them when we were doing completing the square. Don't know if you remember well, about 2-3 months ago. So when we were trying to do completing the square, we had that most of the time we had a equal 1. So every time you see something like this, ax squared plus bx plus c, we call this a quadratic function. And we did some of it as well when we were doing factorization. Remember, ma'am? Does that ring a bell? Multiply, add. So that's what they call quadratic. It's called quadratic as opposed to your straight line because you've got a coefficient here in front of an x square. The straight line would just be bx plus c, whereas a quadratic, the function will be slightly different than a straight line. We'll look at them, what they look like. So the simplest quadratics is when b and c equal 0, and you've got this form f of x is a x squared. Okay, so let's have a look what an f of x equal ax squared looks like. So all of these are function in that form f of x equal ax squared. So let's pick the first one, the red one, yeah? I've got when x equal 1, between 0 and 2 here we've got 1, y equal 1. When x equal 2, y equal 4. When x equal 3, y equal 9. And when x equal 4, y equals 16. Okay. So another one would be the blue one. A equals 3. You get another quadratic, what we call a parabola. So the function, the quadratic, simple quadratic function here would look like this. When x equal 1, this time I've got 3 times 1 is 3, y equals 3. When x equal, let's pick 2, 2 times 2 is 4, 4 times 3 is 12, so 2, and you can see the point here, 12, etc. So, and then they've done 5x squared. So as you can see, the bigger a is, the closer or the smaller space you get in your parabola. So basically it squeezes the parabola in when you increase a. If you use a negative, basically it flips your parabola into that side, in the negative side of y. So you've got a mirror against your x-axis. So that minus 2x squared is the same as x squared, but just mirrored across. So it's a symmetrical. Okay. So key features, whenever you're going to have fx equal ax squared, you're going to see a symmetry about x equals 0, basically. So we've got a perfect symmetry here where x equals 0. And you get what we call a turning point or a vertex. So at 0, 0 is your lower point when you've got a positive, or if a is negative, 0 become a maximum turning point, we call it. Okay, so the bigger the value of a, the steeper the curve, and minus x flips the curve. Can we try and unmute ourselves, guys? Because I think I can hear. Can you hear the background noise? Okay. So, example 1, the parabola has the form y equal kx squared. So we've been given this graph. We've been told that there is a point. So remember, you represent your point as an x here for the first coordinate and y. There's a point 3, 36, which lies on the graph. The first question you could get asked during a simple parabola question, a quadratic, would be find the value of k. Okay, so to do this, what you do is, because this point belongs to that function, that means when x equals 3, if I substitute x with the value of 3 there, I should get y equals 36. Okay, so that's how simple it is. You just substitute f of 3 is 36 because y is just f of x. So 36 is just k times 3 square, k times 9 or 9k. You divide by 9 both sides and you got k equals 36 divided by 9, which is 4. So if you are given a function like this, where you see 3 and 36, you could point that this function is just y equal 4x squared. And you can quickly check that it works by just substituting back in. 3 times 3 is 9, and 9 times 4 is 36, which works for both. So you can quickly check that your answer makes sense, okay? So that's how you would do it. You would just substitute in x for 3 and y for 36. So let's have a look at a different example. So it's the same example, but this time I've got 2 and 100. So remember, x is this point here, and y is this point. We're going to substitute in. The solution is f of 2 is 100. So 100 is a times 2 squared, which is 4a. Then a is just 100 divided by 4, which is our 25. So final answer, f of x is 25x squared. So write down the equation was the question we were asked, and we've just written it down. Okay. Next one, I've got another example here. I've got a diagram here showing the parabola with the equation y equal kx squared. What is the value of k? So this time, instead of them giving me a point, they've given me a graph. So within that graph, I can pick myself a point. So I'm going to pick any point on this graph. So if you want, we can pick an easy point, x equal 2 and y equal negative 16. So that's the point there that we've picked, x equal 2, y equal negative 16. You could have picked x equal 1 and y equal negative 4 if you wanted to. You should get the same answer. So once you've picked your point, then we're back to the other exercise we were doing. You just write that negative 16, which is y, is just k times x squared, which is 2 squared, so 4k. So if 4k equal negative 16, k is just negative 16 divided by 4, which is negative 4. That's it. What is the value of k? K is negative 4. So that is a question that is quite commonly asked doing a parabola question, so that would be 2 marks for you to be able to substitute and to solve the equation. Yeah? So the equation is y equal negative 4x squared. Now, check that the graph has a maximum turning point. Remember we said a is negative, so quickly check that. K must be negative. Choose another point. So we said we can choose 1 and negative 4. So if x equal 1, y equal negative 4. So the left-hand side is negative 4. The right-hand side, this is you checking with the point, which is k equal negative 4. So it's just a way to quickly check your work before you move on. Yeah? So homework number 2, try Nat5 exercise 16a. So we went through chapter 21, 22, and now we're back to chapter 16 because we do all the quadratic at this time, 16, 17, 18, and 19. So question 1 and question 3, page 149 and page 150. It's just those kind of practice, looking at y equal kx squared type quadratics. So let's see, I might be able to do. So one, yeah. So we'll do one of them together. So the question is, we've been told that we've got y equal kx squared. Write the equation of the function. So identify the value of k and write the equation. So I'm going to pick C, for example. Okay, so we've been told that y equal kx squared. First thing first, I'm going to pick a number, easy number, x equal 1, y equals 6. So you just say, okay, I'm going to pick these two. When x equals 1, y equals 6, I'm going to substitute those two in here. So 6 equal k times 1 square equal k or 1k. So 6 equal k or k equals 6. I'm going to rewrite this as y equals 6 x squared. And that should be me. I'm going to quickly check that what I've put here is correct. I'm going to pick a second point. So 2 and 24, just to check that works. So 224. So if I put 2 for x, 2 times 2 is 4. 4 times 6 is 24. So I'm happy with that. A is positive. So I've got a smiley face. So that's what they call a parabola with a smiley face, because A is positive and you've got a minimum turning point at 0, 0. Yeah, so you just write A positive. I've got a smiley face. And I'm happy. So that's how you would do it. Easy to two marks to get. Okay, so I'll let you do the other ones. So I've got here, similar to what we've looked at this time, they ask us to find the value of P, find the value of M, find the value of K. Yeah, so they're all very similar. Okay. So we didn't do completing the square then, because I was asking you if we had done that. I can't remember. Okay, so the next stage, or if we've done it, just see as a revision work. So once you're going to finish those homework, the simple one, the next is to look at completing the square. What do they mean by a process of completing the square? We'll look into it. And using that will help us to find some properties of parabola. So now this time we're looking at quadratic equations, and they're in the general form ax squared plus bx plus c. So is there an easy way to be able to easily sketch them and read some key information? Someone came up with what they call completing the square format, which looks like a times x plus b square plus c. Those ABCs are not the same value as those ABCs there. Okay, different. So let's see some example. It become a bit clearer. So if I've been asked to complete the square for this function, x squared plus 2x plus 3, and hence sketch the function, what do I need to do first? So first thing first, we are trying to rewrite this in this format, a times open bracket x plus b squared plus c, and that should be equal to x squared plus 2x plus 3. So the first thing you look at is the coefficient of x is 2. If I halve that number, I get x plus 1 square. So if I was to halve this number here, x squared plus 2x, the 2 becomes x plus 1 square. But because x plus 1 square adds a 1, we need to compensate it by taking it away before we put plus 3 again. So for this line here be equal to this line, we need to take away a 1 when we write it with a x plus 1 square. That's what we do when we complete the square. And then you tidy up, so x plus 1 square plus 2. So as you can see, b is 1, c is 2, and a is just 1. And we've completed the square. This function here, x squared plus 2x plus 3, we've rewritten it as an x squared x plus 1 square plus 2. And that's what they call completing the square. So let's do a bit of practice before you can become a bit more confident. So now that we've got this, they ask us to sketch the function associated with this x plus 1 square plus 2. So to sketch this function, what you look for is what we call the minimum turning point. So the minimum turning point will be attained when x plus 1 is 0. Because we're adding two positive numbers here, a square number is always positive, the minimum that we're going to get is 2. And this minimum will occur when this part here is equal to 0. So when do we get x plus 1 equals 0? When x equals negative 1. So you take away 1 on each side, you get x equal negative 1. And that's why the minimum turning point is negative 1 and 2. Okay, so that's one thing that tells us about the graph. So we've got negative 1 here, and 2, that's our minimum turning point. The next thing that we need to sketch is where do we cross this y-axis? So this is what we call the y-intercept. This will happen when x equals 0. So you can see when x equals 0, I've got 1 square plus 2. So 1 square is 1 plus 2 is 3. So this is what we call the intercept here. This point here, which is 0, positive 3, is the y-intercept. And this is our minimum turning point, negative 1 and 2. And we've got an axis of symmetry, which run right through here, which is where we hit the turning point. So if someone asks us, what is your axis of symmetry? You say it's x equal negative 1, because that's the line, x equal negative 1 there. Okay, so negative 1, 2, 0, 3, oops, go back. That's what we just saw there. And I'm just going to add a bit of note here. This is what we call axis of symmetry. Okay, so you've noticed that from an x squared plus 2x plus 3, we went to put the completing the square form, and quickly we've managed to draw our parabola. So that's the idea of completing the square, being able to draw a graph or sketch a function quickly. Okay, so let's look at this function here, x squared minus 4x plus 6. So first thing first, I know this is going to be a happy face again, because I've got my coefficient for x squared, which is this invisible 1, positive. The first thing, I'm going to complete the square like they've asked us. So to complete the square, we said we look at this number here, which is a coefficient of x, we halve it. And that would give us x minus 2 square. And then we need to compensate it. And to do that, because we've got x square minus 4x, half the x term and square the coefficient, we need to compensate by taking away 4. And that would become here x minus 2 square, because you will add negative 2 times negative 2, which is plus 4. To compensate it, you take it away. And then you just add your 6 there. And your completed form will be x minus 2 square, negative 4 plus 6 is positive 2 plus 2. Okay, so next they've asked us to sketch this function. So first thing first, to sketch the function, I would just go x minus 2 square plus 2. I will reach the minimum turning point when x minus 2 equals 0 or x equal 2. So minimum turning point 2, 2, which is what we see here. When x equal 2, y equal 2, that's the minimum where we hit the bottom. And to find the intercept, we said that's when x equals 0. So 0 minus 2 is negative 2. Negative 2 square is 4. 4 plus 2 is 6. So we've got our point here, 2, 2, minimum turning point, 0, 6 for the intercept. And they've not asked us the axis of symmetry. So basically what we were asked to do was to complete completing the square for this function and sketch the parabola associated with it. Okay, so I think I've left this as a demo. So if you want at home, you can click on that and that will give you a few different parabola that you can play with. Okay. So sometime they can ask us to express completing the form x plus a square, but instead of the plus b like we were saying, they might ask us to write it as take away b, for example, and then sketch the function. So to do that, we do exactly what we were doing. We half the 2. So the first thing you do is you rewrite this as, oops, need to grab a pen first. So to do this, you half this coefficient here. So you would rewrite this as x plus 1 square. Because we adding a 1 square here, we need to compensate it. We need to take it away. Minus 1 minus 8. And that's when you tidy up and you get x plus 1 square minus 9. So that's the bit that people would miss sometimes, is the compensation. So now if you're asked what is the value of a, you would just say a equal 1, because that's what we've got here, and b equal 9, not negative 9, because it's sub b, sub 9. So this is how you would sketch it. You would find the turning point. So the turning point happen when x equal negative 1, which is here. And when x equal negative 1, we've got y equal negative 9. So that's the turning point. And if you were to look for the intercept, you get that when x equals 0. 1 square is 1. 1 minus 9 is negative 9. So you've got here what we call the intercept. And that gives you all the marks. So negative 1, negative 9, 0, negative 8. And you should be able to just draw or sketch. Okay. So on another example, instead of negative b here, they've asked us to rewrite it as an x plus a squared plus b. I'm just going to do exactly the same thing. So here, I'm just going to say this is x plus half of this number, which is 3 square. Because 3 times 3 becomes 9, I need to compensate that, take that away, plus 11. And when you tidy up, negative 9 plus 11, you get positive 2. So a is 3, b is 2. So that's my first one. Then sketch the graph y equal f of x. So if you had an x square on its own, you would move this x square 3 places to the left, because it's got plus 3. And then because it's plus 2, it goes plus 2. So this is how it would look like. So we've got a minimum turning point at negative 3. So that's when this equals 0. I mean, x equal negative 3, y equal 2. That's your minimum turning point. And the intercept is when x equals 0, 3 times 3 is 9. 9 plus 2 is 11. Okay. So if you were asked to draw this, this is how you would draw it. You would say negative 3, 2. That's your first minimum turning point. And then intercept at 0, 11. Draw that. And then use that as your symmetry line. So if you got 3 squares here, you just put 3 squares here. You would just put that wee dot there and just draw your parabola. Okay. So completing the square and sketch the graph is something that is quite commonly asked as a question. And that could give you up to 4 or 5 marks. So if you do homework 3, exercise 16b, and you just do question 1 at page 156. Okay. So it's just completing the square, then sketching the graph. I'll check again, but I think in the expressions and formulae, we probably touched on completing the square. So that should be a bit of revision, but it's just the sketching part. I guess it's where you just need to work a bit. So you don't need to have special paper for it, you know, to the millimeter. You can use any wee square. That should do. Because usually when they ask for sketching, it's even on a white paper, you should be okay to sketch. So these are the type of question for question 1. Let me check. So I've got A, B, C, D, E, F. So we're going to do E, A, B, C. So let's see the question. So we've been asked to look at this parabola. They've got x plus p squared plus q. For each value, identify the value of p and q and write the equation of the function. Okay, so what did we say? Let's have a look. We're going to try and do this one, 4, negative 2. So because I've got p and q here, first thing first here, I've got this minimum turning point, 4, negative 2. That happens when you've got x minus 4 square minus 2. So this function, f of x, when x equals 4, y equals negative 2. And you can quickly check, if you had x equals 0, you would get negative 4 squared, that'd be 16. 16 minus 2 would be 14. So that's why you can't see it there. Okay. So we can ignore those p and q. Don't need them. We know there. Ignore p and q. Just what you've been asked here to do is find f of x by looking at the turning point. For this one, I've got f of x equal x, this time minus 2. When x equal 2, I hit the turning point, square. And when x equal 2, they've told me y equal 4 plus 4. I I can quickly check that when x equals 0, negative 2 squared is 4. 4 plus 4 is 8. You get this 0.8 point here. Okay. So if I were to look at the question again, x plus p squared plus q. So to identify x plus p squared plus q, in this example, p equal negative 2 and q equal positive 4. And that's why I said to ignore these p and q here. They've got no reason to be here. Okay, because p is negative 2, and I don't see any p being negative 2, and q equals 4. So whoever put that in the book made a mistake. So ignore p and q. Again here, when you do this exercise, ignore that p and q here. That's not your answer. You need to complete the square based on the turning point that you have here. Okay, so it's just writing your way back from a graph. How do you write the function? Now, if they had asked me here, can you write this function as f of x equal ax squared plus bx plus c, then what I would need to do is expand this x minus 2 square. So that would be x squared minus 4x plus 4 plus 4. And that is just x squared minus 4x plus 8. So that's this function here that represents that parabola, x squared minus 4x plus 8. So if they had asked us what is a is 1, b is negative 4, and c is 8. Based on us knowing that quick method of completing the square when we know what the turning point is. Okay, so that's quite powerful, because with just one turning point, you can rewrite the function as it would have been given to you from the start. Okay, and like I said, parabolas are used quite a lot in a lot of real life scenarios. We've mentioned that before. So if someone is asking you to calculate the tension of a cable on a bridge, for example, they might use a function like this. And then you can plug that into a simulator, and they might say, okay, those cables need to be that kind of diameter in order to be able to pull, to hold the bridge properly if 100 lorries are going onto it. So they use parabolas functions. Okay. So you'll be able to do these. Again, ignore P and Q there. They've got no value to be here. Okay, so for the next section, if you want, we can take 5 minutes break, and then we'll quickly look at the starter question before we attack our last hour. Yeah, it's up to you guys. Have a quick tea or something. Not a quick tea, something to drink.